Here we have the situation. Cammie's investing $6,000 and earns 10% interest each year. So we'd like to know what type of sequence this is and then write some equations to represent it. Well, I'm going to go ahead and start with the table of values on this one. I'll start with y for years, and then over here I'm going to say b of y. This is year and the balance of her account, balance as a function of the year. So at the beginning of year 1, Cammie has $6,000. And after another year, she has earned 10%. Now 10% of $6,000 is $600. So now she has $6,600. And then at the beginning of year 3, she's going to earn 10% of this whole thing here. Now 10% of $6,600 is $660. So this becomes $7,260. Now the question here is our pattern adding or multiplying? Well, we can see here that we're adding 600, but there we're adding 660. Those are different amounts, which means this is not an arithmetic sequence pattern. This has got to be geometric. And indeed, every time we see a percent increase or percent decrease, that will end up being a geometric progression. So we want to know what we are multiplying by. Now, if we're not quite sure, and it can get kind of weird with percentages, but if you don't know what it is that you're multiplying by, remember that you can always get your common ratio, which we'll call R, by taking a number and dividing by the number before it. So I could take 6,600 and divide by 6,000. Okay? And if you type this into your calculator, it gives you 1.1. Okay? Or you could write it as 11/10. I'll go ahead and leave it as 1.1. It's important to interpret this in terms of our the numbers that we have here, what's going on. Well, this 1.1, I'm going to write this in a slightly different way. I'm going to write this as 1 plus 0.1, okay? Or, in percentages, that's 100%, and then plus 10%. What's happening here, what we're saying is that the balance after a year will have 100% of what we had, and an additional 10% of what we had. Okay, and that's where this 1.1 is coming from. So the multiplication, we're multiplying by 1.1, and that is true for each stage here. So that is our common ratio. This is a geometric sequence. The recursive equation, the balance at the beginning of year y, will equal the balance the year before, and then times that 1.1. Again, we will always indicate our starting value. B of 1 is the 6,000, the starting balance. And then finally, we need our explicit equation. I'm going to go ahead and do this explicit equation in a slightly different way instead of writing everything out so that we can start to develop that skill. We are starting off with $6,000 in this account. And we know that we're going to be multiplying by 1.1 a certain number of times. Okay. Now, because we're going to be doing repeated multiplication, we know we're going to have an exponent up here. The question is, what will that exponent be? Well, for year 2, we make 1 jump. For year 3, we make 2 jumps. Okay. For year 7, we're going to have to make 6 jumps. So the number of jumps, or number of times we multiply by 1.1, is 1 less than the year number. So that's year minus 1. And that's going to be our explicit expression. I don't actually have my b here. I should have b of y equals. And that's my explicit equation.